Okay, hi everybody. Here is the lesson or the video, I should say, for lesson 1 of chapter 8 and 9. So just to explain why I'm doing chapter 8 and 9 together, they're both very short chapters. Chapter 8 is only a few lessons, chapter 9 is only a couple lessons, and they have very similar content. So I've just combined them into one big chapter instead. So just to let you know, you will have 3 lessons in a row, lesson 1, 2, 3. And then on Friday, we're going to pause. We're going to have a bit of a work period, get caught up on a few things. And then we're going to have our first quiz on Monday. So it's been a while since we've had a quiz. We will have a quiz on this chapter. And then we'll do the second 2 lessons and then we'll have an exam. But we'll talk about that when I get back. Okay, so chapter 8 and 9, we're going to be graphing a little bit. It's not too complicated though. We're going to be graphing straight lines, but what makes it a little bit more tricky is we have to shade a solution region, first of all, above or below the line we draw. And then we also have to make sure our line is the correct type of line. It's going to either be dashed or solid. So here I've written out kind of the 4 possibilities for you of the 4 different types of graph we're going to see. So first of all, I just want to remind you of this slope-intercept form, y equals mx plus b. You learned about that back in grade 9, right? M, so this value right here is the slope, so our rise over run of our line. And then our b, so the number at the end, the constant at the end, this guy here, that's our y-intercept. That's where we're going to start on the y-axis. Okay, so this is going to come back very naturally to you because you have done this before. Okay, here, you're going to see here that there are 4 different types of inequalities we're going to see in this chapter. So we're not dealing with an equal sign. Every single equation I give to you is actually going to be an inequation this chapter. So this first guy here, this is a symbol for greater than, and it's not also equal to. So it's just strictly greater than. So if it's strictly greater than, you don't have that equal sign, that's how you know your line, when you draw your line, is going to be dashed. Okay. And then because it's greater, this is a symbol for greater than. That means we are going to color above the line. So our line would look maybe like this, dashed, and we would shade above. Okay. This next one is strictly less than. Again, we are not equal to, so I know I'm going to have a dashed line, but this time I will shade below because I am less than. So I want to color in the values that are lower or below my line. So it would look like that. Okay. Option number 3 is greater than again, but now we see we have this equality also. So when you have the equality, that's how you know it's going to be a solid line instead. And again, just like the first one, because it's greater than, we are going to shade above. So this one would look solid and we'd shade above. And the 4th and final option is less than, but also equal to. So again, we have a solid line and we will shade below where the values are less or getting lower. Okay, so those are our 4 options. So we're going to get right into a graphing problem here. The first thing I want you to always do is take a look at your inequality and isolate y. Okay, we want to get this into y equals mx plus b form, which means we need y to be all by itself on the left-hand side preferably. So the first thing I'm going to do is I'm going to take that 4x, it's like I'm going to pick it up, I'm going to toss it to the other side, and when that happens, its symbol will change. So it'll look like this. I'll have just a 3y by itself, greater than. That 12 is going to get shoved down, and that negative 4x is now over there. And just put a positive or an addition symbol in front of the 12. The 12 is positive, but we need that plus sign now to separate those 2 terms. Okay, next I'm going to divide by 3, and you need to divide every single term by 3 to be fair. And I have y isolated. I have negative 4 over 3 x, you can't reduce that, so you leave it as is, and then 12 divided by 3 is 4. Okay, so my slope, I'm just going to write this out. My slope is negative 4 over 3 if written like that, which means we're going to go down 4. So my rise is actually negative. So I'm going down 4, and then my run is positive 3. So I'm going to go to the right 3. Just keep in mind that that negative can always shift to the other term instead, and the line will look the same no matter which of these two slopes you use. If you use the second one, your rise is positive 4 and your run this time is negative, so your run is going to the left 3. Regardless of which of these directions you choose, your line will look the same. And then our B value, which is our y-intercept, is at 4, so we know we are going to start our graph on the y-axis at 4. Okay, so let's go. I find 4 on the y-axis, 1, 2, 3, 4. That's what you do first, and then you do your slope. So I'm going to show you both of these. So if I do this guy first, I would go down 4, 1, 2, 3, 4, 1, 2, 3 to the right. Or I could have gone the other way, which meant up 4 and 3 to the left. You'll see that regardless of which way you go, it's going to create a straight line. Okay, you could have kept going from this point and done another 4 down, another 3 to the right. It doesn't matter which direction you go for me, but I do want you to try to get 3 points minimum. Okay, sometimes you won't be able to, you'll run out of room on the graph, but if you can, I'd like you to get 3 points minimum. All right, so then before you connect your dots, take a look at your inequality. Okay, so that means we are going to have a dashed line because we don't see an equal sign. So when you connect your dots, make sure you have a very clearly dashed line. Tack arrows on both ends because we could keep going in theory, right? And then now we have to do the solution region. And because we are greater than, I'll just draw that over here. This is greater than. We are going to shade above the line where our y values are getting higher. So we don't shade down here. Our y values are getting lower down there, right? We want to shade up there where our y values are getting bigger. So that means we're on top of the line. So this whole thing is the solution region. Okay, you may remember this a bit from Foundations 20. Okay, so what this solution region means is that I can now choose any point in this area. So this is the point 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. That means if I take these x and y values and I plug them into my equation, or my inequation, I should say, it will hold true. So I'm just going to do a little verification to show you what I mean. You do not have to do this for every question. I just want to show you what this solution region actually means. So if I take my inequality, y greater than negative 4 over 3x plus 4, and I plug in those two random values I just chose, so both of them just happen to be 5. And if I simplify, I don't have to simplify my left side, it's done. If I simplify my right side, and you can use a calculator for this, you would have negative 20 over 3 plus 4. And you can just use decimal. So 20 divided by 3 is negative 6.7. Oh, goodness. I did not do that on purpose, 6, 7. Okay. And then we're going to add 4 to that. Your final inequality would be 5 is greater than negative 2.7. Is that true? Yeah, it is true. 5 is greater than negative 2.7. Okay, so that's what this solution region means. Any single point in this red shaded area here will make the inequality true. If I chose a point down here and I tried to plug it in, it would not hold true. So that's what that solution region means. Okay, let's do another one. And I chose this one for a reason, because if I go to isolate y, just like I was doing before, I'm going to send that negative 6 over, and it becomes positive 6 on the other side, and that 10 gets shoved down. The reason I wanted to show you this example is because at this point, I have to divide by a negative 2. And that's important because if I divide by a negative 2, First of all of my symbols on the right will change to a negative 3x and a negative 5, but also whenever you divide by a negative and an inequality is involved, the direction of your inequality will change. So watch out for that. That is a very common mistake. Students are working so quickly because they've done so much of this before. This is nothing really new, that sometimes we forget to slow down and flip the symbol. So we have gone from a less than to actually a greater than. Okay, my slope here is negative 3. And we always have to remember that slopes, if there's no denominator, you have to remember that it's truly a 1 on the bottom. So we are going to descend or go down 3 and to the right 1. Okay, if you forget about that 1, a lot of students just go down 3 and stop. You have to go over 1. Or we could flip it and we could go up 3 to the left 1. And then my y-intercept is my constant on the end, which is negative 5 now. Alrighty, so I'm going to go start on my y-intercept, which is negative 5. And then, again, I'm going to show you both directions. So I could go down 3 to the right 1. Now, I cannot do that anymore. I would fall off the graph. So I'm going to now work my way up and do the other slope, which is up 3 to the left 1. Okay, so that's a minimum of 3 points. You could stop there, but just remember that when we're drawing our line, we kind of want to split our graph into 2 portions, either above or below. So if we just stopped and connected that, and I went to go color above, you technically have to color over here too, because technically this line actually continues forever. So I suggest, if you're using a ruler, which you should, even if you draw 3 points only, to still try to extend this line as far as it'll go to actually split your graph into 2 portions. So, or you could just keep drawing a few extra points, and now when you connect your line or your dots, you have a line that splits your graph into 2 very clear sections above or below. Okay, and you'll notice I drew a solid line on purpose because I have the equal to sign. And then this direction is greater than right here. Remember, we flipped it. So greater than means above, or where are our y values higher? They are higher there. So that means we have to shade this entire region. And that means that any points that fall in the shaded area will make the inequality true. Okay, moving on. This time I give you the graph and I want you to create the equation. This is a little bit less work. All we have to do is find out where the y-intercept is. So that's down at negative 4. And I chose this question on purpose because you'll see that our scale is 2 ticks for every unit. So we have to be careful with our jumping, really careful. Okay. The next thing you're going to do is choose a second perfect point. And by a perfect point, I mean where the line intersects your 2 grid lines perfectly. So I'm just going to choose the x-intercept. I'm not going to choose, I don't know, that, because I can tell if you zoom in, that's a half point. I don't want to go there. I want solid, nice whole points. Okay, now I have to figure out what my slope is. So I have to travel between these 2 points. So to get from negative 4 up to 2, I have to go up 1 to get to negative 3, right? So just be careful. I'm actually bypassing a tick. I want to get from negative 4 to negative 3. So I'm going to do 1 big hop, which actually is me going over 2 boxes. And then I'm going up another unit to negative 2, and another one, and another one. So I've gone from negative 4 up to 0. Yes, it was 8 ticks, but I actually only went up 4 whole points, if that makes sense. Same thing here, 1, 2, I went to the right 2. Now, my slope would be 4 over 2, which is 2. If you hopped the other way every single tick, you would actually get the same answer. 1, 2, 3, 4, 5, 6, 7, 8. As long as you did the same thing here, 1, 2, 3, 4, you would get 8 over 4, which is also 2. So you could have hopped every single tick. As long as you did it on both directions, your answer will be the same. Okay, so either 4 over 2 or 8 over 4, regardless, we are getting a slope of 2. So my M is positive 4 up, positive 2 to the right. We reduce always, my slope is 2, and my y-intercept is this guy right here, negative 4. So I just put those together in an inequality. Remember, don't write an equal sign because we're not doing equations, we're doing inequalities. So I would have y, I would have my slope of 2x and my intercept of negative 4. And now I got to figure out what goes here. I see I have a solid red line, so I know I'm going to have an equality symbol. And then if I look here, this shaded region is underneath or below my line. That means less than. There we are. Done. Okay. One more like this. You'll see here that the 2 points are drawn in for you, so you might as well just use those. I'm going up 1 to the right 2. Now, I just want to let you know that if you go the other direction, like you could start at this point and travel the other way, that's fine. That means you would be going down 1 and to the left 2. Regardless of which option you use, you would have 1 over 2 if you chose the black numbers, or you would have negative 1 over negative 2 if you chose the red numbers, which just reduces to 1 over 2. So it doesn't matter what direction you go, as long as you watch your symbols, right? You went down and to the left here, so both are negative. As long as you watch your symbols, it'll all work out to be the same thing, okay? And then your y-intercept is this guy right here, which is at a y value of positive 2. Okay, so y, my slope is 1 over 2x. Don't forget to attach the x to it. And then my y value was a positive 2. I see a dashed line, so I will not be drawing an inequality or equal to sign. And I see that I am shaded above, which means greater than. And so it is just like that. Okay, we're getting there. 2 more guys down here. No graphs right now. Okay, so the very first example I showed you, we talked about how this 0.55 I tested was part of the solution region, and we proved it right here, right? So what I'm asking you down here is, I'm asking, is negative 2, negative 5, is it a solution to this guy? What that means is if I were to draw this line and shade, would this be in the shaded part? Yes or no? So you don't have to actually sketch it to figure this out. All you got to do is plug in the x and y values into the inequality I give you. And you don't even have to isolate y here. Just use it as is. So I would have 3 times y, but y is negative 5, is greater than 2 times x, but x is negative 2, minus 7. So you've got negative 15 on the left. You've got negative 4 minus 7 on the right. So in the end, don't move stuff around. Just simplify each side. You have negative 15 greater than negative 11. And you just ask yourself, is that true or false? Is negative 15 greater than negative 11? No, it's not. It's smaller. So this is false. So that means that this point, negative 2, negative 5, is not in the solution region. So it would not be one of the shaded points. Okay, let's do one more like that and then we're all done. This time I'm giving you negative 1 and 1, and we're going to use this guy. You don't need to isolate or anything, just plug in as is. So 4 times x, but x is negative 1, minus y, so just minus 1, is less than or greater, or sorry, less than or equal to 5. So I would have negative 4 minus 1. Don't move stuff around. Like, don't go plus 1, plus 1. That's if you're solving for something. We are not solving for anything here. We have no variables. So don't move stuff around. Just simplify. Negative 5 less than or equal to 5. Is that true? Is negative 5 less than or equal to 5? Yeah, it's less than. So that is true. So that means this point, negative 1, 1 is, is in the solution region if we were to graph this guy. Okay, so that's it. Not too bad. Here's your assignment down there. It looks like a lot, but a lot of the questions are really, really quick. Okay. I made sure there was graphing paper in the gray baskets in the corner of the room up by the board. So go help yourself because you will have to do some graphs. Today is Tuesday, so this is due on Thursday. Okay, I'll see you tomorrow.